Hello, my name is Brian Wiebe, and during the summer after my sophomore year, I began a programming internship at the UC Davis Tahoe Environmental Research Center, or TERC for short. During my internship, I worked on 3 engineering projects that enable the public to view the atmospheric conditions around 2 California lakes and understand the effects these conditions have on their lives. I started by creating an informational web page that displays both UV and air quality indices in the Tahoe Basin, using data from radiometers and optical particle sensors. The HTML and JavaScript program takes the real-time measurements from the UC Davis instrument and open-source air quality sensor APIs, calculates the dynamic indices using the complex formulas, and displays them on a web page available to the public from the TERC homepage. During the devastating wildfires of 2020 in California, the sensors provided vital information to the public when air quality was extremely unhealthy. My next assignment was to create interpolated wind maps for Clear Lake, California using UC Davis TERC instruments. These maps use data from 7 meteorological stations on the shoreline and then calculates an estimated speed and direction of wind for that point. I developed a weighted interpolation method that weighs speed and direction for the interpolated point based on the distance to the other 7 meteorological stations. The closer the point is to a station, the larger weight that is associated with wind speed and direction from that station. From these calculations, I was able to create 2 types of maps to showcase this data, a vector wind map and a streamline wind map. This vector map that I developed indicates wind speed and direction using a grid of arrows. The direction and magnitude of each arrow signifies the movement and speed of the wind across the lake. The next type is a streamlined wind map that uses small dots to mimic air particles affected by the wind. My animation displays the wind using dots with a waning transparent path left behind, signaling the route that the particles have traveled. By creating these maps, the public was able to access the current and past wind conditions over the lake that was not available before, allowing them to make smart decisions while boating or enjoying other water sports. After successfully completing the wind maps for Clear Lake, I was asked to do the same for Lake Tahoe during my senior year. Lake Tahoe, unlike Clear Lake, has NASA mid-lake buoy stations. These buoy stations upload data every minute, causing the data acquisition protocol from the instruments to time out. Here is a sneak peek of the maps under development as I continue to optimize the program and work with a UC Davis API engineer to reduce the data size to ensure a short load time for the next 5 maps that will be used by the residents and visitors of Lake Tahoe. The API for these projects in Clear Lake and Lake Tahoe include thousands of data records that had to be parsed, sorted, weighted based on the distance from each station, averaged for each dot and arrow, and graphically displayed using only HTML and JavaScript. In addition, many hours of research were spent discovering how to draw using programming code, creating recursive functions for maximum efficiency, and testing the accuracy of the result. Throughout this internship, I encountered lots of challenges, everything from incorrect interpolation outputs to limitations of programming languages. However, I persevered, crawling through my code to improve performance of data acquisition protocols and researching equations that use particulate matter and wavelength measurements. Although I developed all of the programs personally, I collaborated with UC Davis TERC researchers and grad students regarding the scientific aspects. To get programming advice, I worked virtually with the UC Davis API engineer and conversed with programmers on Stack Overflow from all across the world. I enjoyed how I was able to explore beyond computer science. My curiosity led to understanding wind patterns and atmospheric effects on the environment. Thank you for taking the time to learn more about my engineering projects.